initial center of mass position from the shore. From the shore, what is the initial center of mass position? Let it be x. Let this be x-axis, y-axis the vertical. Choose coordinate axis. Therefore, center of mass, initial x coordinate of center of mass. Center of mass x coordinate is the person is of mass 40 kg. Initial position of the person from the shore is 3 meters plus mass of the boat is 80 kg. Initial position of the boat is 3 plus 2.5, 5.5 meters, where the center of mass of the boat is assumed to be at the middle of this. Therefore, 2.5 meters plus 3, 5.5 meters divided by total mass is 40 plus 80. So, therefore, the center of mass position comes out to be 120 plus 440 divided by 120, that is 560 divided by 120. So, this comes out to be 8 70s, 8 15s, 5 3s, 5 14s, 14 by 3 meter. So, initial position of center of mass is at 14 by 3 meter from the shore. Now, when the person moves towards right end of the boat, let the boat move towards left, because to keep the center of mass, boat move towards left by x. So, when the boat is moving towards x, towards left, then what is the effective distance of the person from the shore now? Therefore, new coordinate of center of mass of the system will be new position of the person. New position of the person is, he is moving to the other end of the boat. Therefore, he has travelled another 5 meters from, he is 8 meters away, but boat has moved x meters towards left. Therefore, it is 8 minus x. 8 minus x meters is the distance moved by the person. 8 minus x meters. 8 meters here, x boat has moved. Along with the boat, the person also will be carried by the boat towards left. Therefore, 8 minus x into 40 plus boat has moved towards left. Therefore, it is 80 into minus x. Why minus x? Displacement is towards left. Or otherwise, we will write, since it has moved towards left as x distance, what is its coordinate now? 3 plus 5.5 was initial position, initial distance. Now it is x has moved towards left. Therefore, its distance is from the shore 80 into 5.5 minus x divided by 120 meters. From this, we will get the value of new center of mass would have been, that is 320 minus 40x plus 440 minus 80x divided by 120. This is, or otherwise we will get 760 minus 120x by 120. That is, new center of mass position should be like this. But we know that as there is no external force acting on the system here, boat and person system, center of mass should not move. Therefore, original coordinate of center of mass, new coordinate of center of mass must be equal. Therefore, equate them. So, original motion of center of mass was, original position of center of mass was xcm is equal to xcm dash, as that is what we have shown. 14 by 3 should be equal to 760 minus 120x divided by 120. So, 340 is 560 is equal to 760 minus 120x. From this what we calculate is 120x is equal to 200. Therefore, x is equal to 200 by 120, 5 by 3 meter. Boat will, as the person walks towards the other end of the boat will be moving to the left by 5 by 3 meters. But problem asked is not displacement or shifting of the boat. What is the effective distance? What is the actual distance of the person now after he travels? He was initially at 3 meters. He has traveled towards right by 5 meters on the boat. Meanwhile, the boat has moved back by 5 by 3 meters. Therefore, this is distance of the person from the shore. Final distance of the person from the shore is this. If the boat does not move, it would have been 8 meters, but the boat has moved back by 5 by 3 meters. Therefore, effective distance is 3 plus 5 minus 5. So, there 5 by 3. Therefore, 24 minus 5 by 3, 19 by 5 meters is the distance of the person once he travels 5 meters from one end of the boat to the other end of the boat. He will be at this distance from the shore. This is one of the examples where the motion of center of mass is useful here, idea. The next example we consider is the boat problem. Once again, another boat problem we will consider. A person of mass 100 kg man is standing at rest on a 50 kg boat which is floating in still water lake, floating on still water lake, and he now walks along the boat from one end to the other end with a velocity 2 meters per second with relative to boat. He now walks on the boat from one end to the other end of the boat with a velocity 2 meters per second relative to the boat. Then what is the actual velocity of the person as seen by shore? From in the reference frame attached to the shore, what is the velocity of the person, actual velocity of the man? For that purpose, we use conservation of linear momentum here. Now, initially, boat and man are at rest. Therefore, initial linear momentum is 0. Final linear momentum at any instant of time, when man starts moving, boat also will be moving. The reason is the boat is not experiencing any external force. Boat-man system is not experiencing any external force. Therefore, boat and man system is center of mass has to be at rest, and the linear momentum of the system is to be conserved. Initial linear momentum is 0. Therefore, final linear momentum m of man, velocity of the man, plus m of boat, velocity of the boat, linear momentum has to be 0. Because initially it is 0, final sum of the total linear momentum should be 0. Therefore, VB is equal to m by mb into Vm. What is mm here? Mass of the man, mass of the boat, velocity of the man. So, because mass of the man is 100 kg, mass of the boat is 50 kg, and velocity of the man is Vm, and velocity of the boat is Vb. So, that shows it is minus 2 Vm. It indicates boat moves with a velocity twice the velocity of the man in the opposite direction. Boat will be moving opposite. If the man is moving towards right side, boat will be moving towards left. with a velocity twice this. But what is given is velocity, magnitude of velocity of the man with relative to the boat is 2 meters per second. Now we will calculate velocity of the man with relative to boat VMB is VM minus VB. And VM, but VB as we calculated from here is minus of minus 2VM. Therefore, 3VM. Velocity of the man with relative to boat is 3 times velocity of the man. So therefore, actual velocity of the man is Vm is equal to Vmb by 3. That is equal to 2 by 3 magnitude. That implies velocity of the man as seen by the shore with relative to shore is 2 by 3 meters per second. So the person will be as seen by a person on the shore. The boat appears to be, or person appears to be moving with a velocity 2 by 3 meters per second. But for a passenger, co-passenger